So what do we do if our mean is not equal to 0 and our standard deviation is not equal 1? Well, remember that if you have any set of data, you can convert that data to z-scores. So if you've got data values x that have a normal distribution, then you can convert those to z-scores, and then that will have a standard normal distribution, which means mean 0, standard deviation 1. So, and it used to be that we convert to z-scores and look up things in tables, but we have technology that'll do a lot of this work for us. So let's look at an example and use the distribution menu to help us out. So IQ scores are normally distributed. They have a mean of 105, standard deviation of 12. So mean, mu, is equal to 105, and sigma, standard deviation 12. And we want to find the probability that a randomly selected person will have an IQ that is greater than 110. So we're looking for probability that x is greater than 110. So on the distribution, we've got a mean of 105 in the middle, and then we would add 12 3 times, subtract 12 3 times. That's the spread of the distribution. We want to know probability x is greater than 110. So 110's to the right of 105. Let's say it's right here. So that is 110. And so the probability that x is greater than 110 is going to be the right area right there. So that is going to be normal CDF. Greater than is right area. And our left cutoff here is 110. Our right cutoff, infinity. So we'll do 110, 10,000. And then just put in our mean and standard deviation, 105, 12. So let's go to the distribution menu on the calculator. So second variables, we want normal CDF. Our lower cutoff, 110. And our upper cutoff, infinity, we're going to use 10,000. Our mean, 105. Standard deviation, 12. Now we can paste and enter 0.3385. And that means that this area is 0.3385. So probabilities are areas, which are also proportions. What's the probability or proportion of the data between 90 and 120? So we've got our 105 in the middle here. 90 would be somewhere to the left, and 120 somewhere to the right. And we want that area right there. That'll correspond to the probability. So we want probability 90 less than x less than 120, which is the area between 90 and 120. So that's given by normal CDF. Our lower cutoff, 90, comma, upper cutoff, 120, mean 105, standard deviation 12. Let's enter that in. So second variables, second variables, there we go. And we want normal CDF. So our lower 90, upper 120, and mean standard deviation still the same. Paste it, enter, 7887. So 7887 is the probability, and the area also 0.7887. And then the last one, we want to know what is the probability that the IQ score would be less than 95. So that's asking probability that x is less than 95. So 105 is in the middle. 95 would be to the left here. And so probability less than 95 is going to correspond to the left area there. So our left cutoff, negative infinity, right cutoff, 95. So this will be normal CDF. Left cutoff, we'll use negative 10,000. Right cutoff, 95. And then mean standard deviation. So let's go ahead and enter that. So second variables, and then we need number 2. And so our lower cutoff, minus 10,000, upper cutoff 95, 95. Mean standard deviation the same, paste it, 0.2023. And that's what this area is, also 0.2023.